Hi, this is Becca, and this is TriTutoring's lesson on systems of equations. We're going to look at two ways to go through and solve systems, and we're looking at systems with two variables, x and y. As we find those solutions to a system, we know that it's going to be one of three types of answers. It may be an ordered pair, infinitely many solutions, or no solutions, and we'll see each of those here. Let's take a look at this first system together. Now, the way that I would solve this system is actually with substitution. The reason I'm thinking substitution versus elimination is because I see one of those variable terms that's already isolated. To use substitution, we find one of the variables, in this case we found y, and we substitute its value into the other equation. So my other equation is x plus y equals 5. Well, I'm going to replace the y with 2x minus 1. I can make that change because I know that's what y equals, so I can change that y. At this point, now I can just solve to get x isolated. Take 1x plus 2x to get 3x minus 1. We want to add 1 to the other side. And then to isolate the x, divide by 3. That means x is 2. Once you find a solution for one of your variables, use it in the original system, either equation, to find whichever term we're missing. So I'm going to use x equals 2 in my second equation. So instead of writing 2x minus 1, I'm going to replace x with 2. I get y equals 4 minus 1. 4 minus 1 is 3. To write my final answer for the system, I would make it an ordered pair x, y. So I would write it as 2, 3. And that's my final answer using substitution. So maybe I have another system, but there isn't a variable already isolated. 7x minus 2y equals negative 12, and negative x plus 2y equals 0. None of those terms are isolated. There's not a coefficient of 1 somewhere. So instead of doing substitution, I'd like to use elimination. Elimination is when we combine the two equations together. Now, in order for this to be successful, one of the variables needs to cancel out. So we're looking for opposites. I notice I have opposite coefficients. If I look at these y's, I have a negative 2 and a plus 2. So I can actually already combine these two equations together, and it's going to eliminate. Adding the two lines together, 7x minus 1x is 6x. Negative 2y plus 2y will cancel out. Negative 12 plus 0 is negative 12. This leaves me with an equation in just one variable. Now I just need to isolate the x. Dividing by 6 on both sides gets x by itself, and negative 12 divided by 6 is negative 2. Now that I have an answer for x, I can use it in either of those original equations to find y. I'm going to use that second equation. My thinking is that it has smaller numbers in it, quite honestly, but both will yield the correct answer so long as I plug it in correctly. So I'm going to replace the x with a negative 2. Two negatives make this a positive 2 plus 2y equals 0. Subtracting the 2 over to the other side, 2y equals negative 2. And then to isolate the y, divide by 2 so that y equals negative 1. To write my final answer, I'll make it an ordered pair, x, y. That would be negative 2, negative 1. Each answer so far has been an ordered pair, but there are special types of solutions as well. On the next system, I want to use substitution, and I'm choosing this because I see that I have this y already isolated. So we're going to use the value for y in the other equation. I'm going to replace x minus the y right there I'm going to replace that minus y with x plus 5. So that value of y goes into the other equation. In this case, I have to distribute, so I will distribute that negative so that I have x minus 5, distributing that negative 1. On this left side, x minus x, if I combine these like terms, cancels out, so that I have negative 5 equals 2. Well, negative 5 does not equal 2. This is a false statement. If I end up losing all of my variables and I end up with a false statement, that tells me this is a no solution. On this last one, I'm going to choose to use elimination to practice a skill where I need to multiply one of the equations. Right now I don't see opposites, but I know that I can make opposites. If I look at 3y and 1y, I know that I would be able to cancel out the y if I had 3 minus 3. In order to achieve a 3 minus 3, we can actually multiply one of the equations by some scalar term. Now, it does have to go to every single term in our equation. So I'm not going to change the first 6x plus 3y equals 54. But I'm going to multiply the entire second line by negative 3. This gives me negative 6x minus 3y equals negative 54. I did that to achieve opposites here. I wanted to have a 3 minus 3 that was going to cancel out. Well, now as I add my equations together, notice I actually have 6 minus 6, which cancels out, and 3 minus 3, which cancels out, and 54 minus 54, which cancels out. I'm left with 0 equals 0. Is that a true statement? Well, yes, 0 does equal 0. If I'm left with a statement that's true, and it's always true, my variables are gone, and it's a number equals itself, that tells me this is my other type of special solution. This is infinitely many solutions. So this was a quick look at using substitution and elimination, how to get each of the 3 types of solutions and determine which method do I want to use here. So thanks for listening, and we'll talk to you next time.